Hi, ladies and gentlemen. This is Mr. Green. This is the first in a series of recordings that I'm going to make, and we're going to be looking today at Unit 1, Lesson 1, which is on foundations. Uh, the foundations in this situation are just things that you have probably done in the past in other courses, other math courses, but want to make certain that we got them covered here so that we can't say that we don't know what we're doing when we're doing some of this stuff. First of all, decimal operations. When you're looking at decimal operations, we're talking about adding and subtracting decimals. The main thing to make certain you do when you're doing this is make certain you line up those decimals. If you don't line up those decimals, a lot of times you'll get answers wrong. For example, if I'm adding 3.62 and I'm adding 4.91, see how I've lined the decimals up here? If I'm going to add those, I need to make certain I line them up so that when I add down, come on, pen, work with me, 3, and 15 here, carrying my 1, and I get an 8. Now my decimal just goes right there. It's real simple to do. And if you're subtracting, same thing occurs, but you always make certain you line the decimals up so that you can do them. I've seen so many times people do this sort of thing, 3.62 plus 2.1, and they're lining the numbers up over here, and then they try to add straight down and say, well, that's got to be what my answer is. Well, it's not. This would not work at all because your decimals are not lined up. Okay? So you want to make certain you're lining them up correctly. Now, when you're multiplying decimals, you can actually ignore that they exist. So 3.62 times 2.1, you can actually multiply this one with and ignore the fact that the decimal is there at all. So 1 times 2 is a 2, 1 times 6 is a 6, 1 times 3 is a 3, 2 times 2 is a 4, so put a 0 there, 4, 2 times 6 is a 12, carry your 1, 2 times 3 is a 6, plus 1 is a 7. Now I've multiplied those. I'm just going to add down 0, carry your 1, 6, 7, 7602. Now I'm going to count the number of decimal places I've got. There's 1, there's 2, there's 3. So I'm going to come over here from this point and count 3. 1, 2, 3. Put my decimal there. That would be my final answer, 7.602. Okay? And it's just by counting the decimals I can get to that spot. So decimal operations are not hard. You probably know how to do those. I just want to make certain we cover that we know what's going on there. The hardest one to do is dividing decimals. Okay? So if you've got something like 7.83 and you're trying to divide that by 0.04, the one thing that you need to do is to move the decimals out of your divisor out here. And see how I moved it 2 decimal places there? That means I need to move it 2 decimal places in here. And by moving that decimal place like that, I'm now dividing 4 into 783. It becomes much easier to do when you do it that way. 38, and let's see here, 9 times 4 is 36. 36, and you subtract, you get 23. So that'd be a 5, and that'd be a 20, and you get a 3, 0, point 0. So it's going to go in there. Point, and go in 75. Except it'll work out that way. But that would wind up being my answer, 195.75. Even though it was only a 7 that I was initially starting with, my number over here in the divisor was so small, 0.04, it went in there 195 times. Okay? Got to make certain that you're following the right procedures when you're dividing decimals. Okay? Now, perimeter. Perimeter is a term you're going to hear a lot about. Perimeter is the distance around a polygon. All you've got to do is add up all the sides. Okay? Now, there are some formulas for perimeter. For example, on a square, you just take 4 times the side, or on a rectangle, it might be 2 times the length plus 2 times the width. But in essence, it's still just adding up all the sides. Okay? Area. We're going to be using area a lot as examples for some of the problems that we're going to be doing. And there are formulas for area that you have to follow. For a square, you multiply two sides together. Or any of the parallelograms, rectangles, you multiply the base times the height. Triangle, you multiply the base times the height and then multiply it times 1/2 or divide it by 2. Either way you want to look at that. If you don't do that, you don't get the right area for a triangle. Those formulas need to be followed, and you need to make certain you remember those formulas. Now, these should not be new to you. These are things you should have had in several grades before now. And I'm just making certain that we've got them covered here so that if there's any questions, you can go back to this and find out how to do them. Okay, powers. What we're talking about there is when we look at some of the equations, some of the things we have, we see this little number up here above and to the right of another number. That is called the power. You're raising it to the power. What that means is I'm going to take that 3 and multiply it times itself 4 times. That's what that 4 tells me to do. I'm sorry. I had 4 and I meant to write a 3. Okay? So I'm multiplying that 3 times itself 4 different times. There are some rules for dealing with them. We're going to talk about those rules as we go along and in some other lessons. But if you see it as a number, your best bet is go ahead and work it out. Get rid of that power so that you don't see it anymore. Write it down as 3 times 3 times 3 times 3. And then multiply it out. 3 times 3 is 9, times 3 is 27, times 3 is 81. And now 81 is easier to deal with than 3 to the 4th. Now, the only thing you need to know about those powers, basically, if it's a variable, only combine the same variables together. Don't try to combine unlike variables. And that'll help you there. So let's get down to what is algebra here just for a second. Algebra comes from an Arabic term. It's from the Arab regions. They were very good at doing some of this math, and so that's why it became known as algebra. It basically means a problem solver. Now, I'm not a linguist. I'm not trying to tell you exactly what it means. I'm just trying to point out to you that that's what the basic meaning is, that it means you're a problem solver. So if you like solving problems, if you like doing games or who done it, then algebra is the math you're going to be using. It's similar in that nature. Okay? We're going to be using math to solve problems. Okay? So it's not something that we're doing just because it's a course I got to take. It is something that has true meaning. It is something that you will be able to use later on in life. Okay? So I've already used the term a couple times, but I want to make certain I define what a variable is. So a variable is the way that you represent a number. That seems kind of weird. But it is the way that you represent a number. It is not the number itself. A number is not a noun. A variable is not a noun. Numbers and variables are always adjectives. They describe some noun. So if you see someone say, I have 5. 5 what? The what is the noun. 5 is just a description of that. Okay? It is a way of describing it. And sometimes we don't know how to describe something. So we come up with a variable to describe it. That's where variables come from. It is simply representing a number, though, a variable is. So let's see here. If you write the number 5 on a piece of paper, like that, that is not a number. That is a variable that represents the number. You've come very used to that being the number 5, but it is not the number 5. 5 is simply a description of something. So 5 sheep would be 5 little animals out there in the field somewhere. Okay? But this is not the number 5. It is simply a variable that represents it. So when we start replacing it with these, with this, x, it is saying the same thing. It's saying X sheep out in the field. It is some way of representing what is out there. And when we don't know something, thus we're going to use algebra, we're going to use some variables to describe what's going on so that we can then discover how many sheep are out there in the field. And that's how we solve problems, is by using those variables to represent unknown situations. Thus begins the trek into algebra. That is what we're going to be doing, is we're going to be replacing these adjectives for numbers with variables and then learning how to solve for those variables, finding out information, discovering facts. That's why we use variables. Okay, that's enough for today. These are things you probably have heard in the past in other classes, and I wanted to make certain we got them covered before we get into our actual algebra lessons. So I look forward to seeing you.